Welcome to part 2 of the dimensional analysis topic. In this video, we're going to learn how to perform one-step unit conversions. But to make sure that we write down our final answers correctly, let's first review the rules for rounding numbers. Let's take the number 61.2537 and try to round it to the different number of digits. These are the rules that we have to follow. If the first digit to be dropped is 4 or less, then the last retained digit of the number should not be changed. Now, if the first digit to be dropped is 5 or greater, then the last retained digit of the number must be increased by 1, in which case we say that we round the number up. Let's try it. First, we're being asked to round to 2 digits. This means that we'll need to drop digits 2537. And in order to round the number correctly, I have to look at the first digit to be dropped. In this case, it's 2. Which case is it? 4 or less or 5 or greater? Well, of course, it falls under the case 4 or less. In this case, I make no changes to the last retained digit, and the rounded number is 61. Next, let's try to round to 3 digits. The first 3 digits I'll keep. That means that I will need to drop 5, 3, and 7. Now, the first digit to be dropped is 5. It falls under this case, 5 or greater, and that means that the last retained digit of the number must be increased by 1. 2 is the last retained digit in this case, and once it's increased by 1, the rounded number becomes 61.3. Notice that we preserve the position of the decimal point. When rounding to 4 digits, the digits to be dropped are 3 and 7. The first digit to be dropped is 3, which falls under the case 4 or less. So we're not going to change the last retained digit. It stays as 5. The rounded number is 61.25. And finally, rounding to 5 digits will make us drop 7. Since that number falls under the case 5 or greater, we must increase the last retained digit by 1. So instead of 3, the rounded number will have 4. So these are the rules that we'll follow if the final answer of a problem requires rounding. Now let's try a few conversion problems. Here's example 1. A rattlesnake is 24.4 inches long. How many centimeters long is the snake? Round answer to 5 digits and check if the answer makes sense. In all unit conversion problems, whether one-step or multi-step problems, we're given a measured quantity using specific units. And we're being asked to find an equivalent quantity, but using different units. So we can always start by writing down the given measurement and stating what we need to find. In other words, stating what units we need to convert to. In this problem, we're given measurement in inches. A rattlesnake is 24.4 inches long. And what we need to find is how many centimeters that is. Simply put, we need to convert from 24.4 inches to the equivalent quantity in centimeters. Well, the process of conversion is done by using conversion factors, or factor if it's just a one-step conversion. Conversion factors can be obtained from the tables of units, or from the equalities given in the problem. Since for this example we need to convert from English units inches to metric units centimeters, the relationship between the two can be found in the table. This table provides various metric English relationships, and that's the one we need for our problem. It relates centimeters and inches. Let's copy it. Now, from the equality that we got from the table, we can obtain 2 conversion factors. 2.54 centimeters over 1 inch and then 1 inch over 2.54 centimeters. The conversion from one unit to another happens with the help of the multiplication operation, which means that in the process we need to multiply by a fraction. In addition to that, the goal that we're trying to achieve is to cancel the original units, the given units, and be left with the new or required units. When it comes to fractions, we know that same numbers, expressions, or units can be cancelled if one is in the numerator and then one in the denominator. Well, that really helps us to make choice between these 2 conversion factors. If I want to cancel inches, they must be in the denominator of the conversion fraction. So that's the one I will use. And this is one of the common ways to organize your work when you perform unit conversion problems. you draw a long fraction bar. You write down your conversion factor or factors. And then you draw vertical lines to visually separate given measurement with conversion factors and the resulting measurement. At the same time, vertical bars can represent multiplication operation, since that's the operation that we need to perform. It's optional but might be helpful to place 1 in the denominator of the given measurement, just to create a fraction out of it. However, as we start performing multiplication, 1s in the numerators or denominators will never affect the answer. Now, before we perform multiplication, let's confirm once again that we chose the correct conversion factor and that the units cancel as we need them. So I can see how I have inches in the numerator, one fraction, and then inches in the denominator of another. Since we perform multiplication, we're allowed to cancel them. And the units that we're left with are centimeters. What's left to do is to multiply 24.4 by 2.54. I performed this multiplication using a calculator, and that's the result I get. The problem asked to round the answer to 5 digits, and I can see that I only have 5, so no rounding is required. I will copy this answer. Here it is. Based on this answer, I make conclusion that the same rattlesnake measured in centimeters will be 61.976 centimeters. And while it might be challenging to check the actual answer without repeating all the steps, we can catch mistakes if we notice that the answer we got is not reasonable. Well, in this case, almost 62 centimeter rattlesnake sounds reasonable, so this answer makes sense. Let's try one more example. It says that a glass of water contains 53.2 fluid ounces. And the question is how many quarts in this volume? Again, we'll need to round the answer to 5 digits if applicable, and check if the answer makes sense. Let's write down what's given and what we need to find. The given units are fluid ounces, 53.2, and we need to convert that to quarts. Once again, this will be done by obtaining a conversion factor. Notice how both are English units, so we need to refer to the table of English units. Here it is. Here we have units of length, mass, but we need units of volume. These are some of the relationships involving quarts, but the one we need is between quarts and fluid ounces. Here it is. Let's copy this equality. Now, based on this equality from the table, we're able to obtain 2 possible conversion factors. So which one do we need to choose? Remember, the logic is that we need to cancel units fluid ounces and be left with units quarts. Well, to cancel fluid ounces, these units have to be in the denominator of the conversion factor. Therefore, we're going to use the first ratio. I copied it here, and I added a long fraction bar and vertical bars. Here I can also put 1 as the placeholder for the denominator of the given quantity. Now I can see how the units fluid ounces are being cancelled, since 1 is in the numerator and 1 in the denominator. The units quarts are left, and that's exactly what I need for my final answer. And now I need to perform the operation. And here we need to be reminded that while vertical bar can be viewed or can represent multiplication, the fraction bar of any fraction always represents division. And since I can ignore ones, the only 2 numbers I have to deal with are 53.2 and then 32. Since 1 in the numerator and then the other one is in the denominator, I will need to perform the division operation. The number that's on the top has to be divided by the number that's on the bottom or in the denominator. This is my work on the calculator. I performed division and that's the result I got. Once again, my final answer has only 5 digits, so no rounding is required here. I'll copy the result. So based on our answer, we found that 53.2 fluid ounces is equivalent to 1.6625 quarts. And that sounds like a reasonable answer for a large glass of water. So this is how one-step unit conversions are performed. The key is to obtain a correct equality, and based on that, choose the appropriate conversion factor. You want to make sure that units that you don't want cancel, and the units that you do want stay. In the next video, we'll see how to perform multi-step unit conversion, which will require several conversion factors.